Okay, hello, good afternoon and good morning and good day to everyone. So welcome back to the Skills Up SuperMap for week 6, where you will learn about spatial analysis. So as usual, I am Anis as your moderator for today. And if you have any question while listening to the speaker, you can just type in the Q&A chat box, or you can just type in the chat box. So I hope you guys will be enjoying this today training session. And also this training will be broadcast live on YouTube and also will be recorded as well. So if you miss some of the content for today, you can just watch it through our SuperMap Malaysia YouTube channel. All right, so let's start right away.
So, hello and good day everyone. Welcome back to our sixth session for Skills Up with SuperMap. So, for today, our focus will be on the spatial analysis by using SuperMap iDesktop ads. As usual, if you have any inquiries, you may type it in the chat box and we will answer your question or query directly. Or you can also email us if you want to know more about SuperMap, or maybe if you encounter any problem when you use the software, you can also email us directly. Now let's take a look about what is spatial analysis before we go deeper about the tools in spatial analysis and the function of spatial analysis. So basically, a spatial analysis is an analysis technique that based on the location and shapes of the geographical objects. Its objective is to extract and transmit spatial information. Powerful spatial analysis capability is the main features of the GIS. So basically, there are two types of spatial data, which is vector data and also a raster data. Therefore, spatial analysis function can be divided into two categories, which is spatial analysis that is being applied to vector data and those spatial analysis that is being applied to raster data. Now we're gonna take a look on our content for today's session, which we will do a vector spatial analysis, raster and 3D spatial analysis, and also spatial statistic analysis. Lastly, we will also do some demonstration for a spatial analysis where we will show you how to do a vector, raster, and also a 3D spatial analysis. Now let's start with our first part, which is the vector spatial analysis. So under vector spatial analysis, we have a buffer zone, overlay analysis, and also proximity analysis. With a SuperMap, and also we can create a buffer zone for the single layer buffer, multi-layer, and also a 3D buffer zone. While for overlay analysis function, we can do intersect, union erase, XOR, clip update, and so on. And for our overlay analysis, lastly for the proximity analysis, we can do the Thyssen polygon function, and we can also measure distance between the objects. Okay, so now we go to our first vector spatial analysis, which is buffer analysis. So basically, buffer analysis is a process of building zones with a certain width around the point, line, or region geometry objects according to a specified buffer distance. So this buffer zone has been used in many fields like agriculture, urban planning, ecological protection, flood prevention, military, geology, and so on. So this is what when we say it can be built with a certain width around a point, line, or region geometry object. So this one is for the 2D single layer, and we can also do multi-layer like the above pictures. that shows you we can do not only one layer, but we can also create more than one layer for our buffer zone, and we can also create a 3D zones here. Next, we have overlay analysis. So overlay analysis is basically a process for generating a new data set by overlaying two data set with a different themes. And overlay analysis results will be carried over the attribute of the feature from two or more original layer. So we will do the overlay and analyze the spatial data, and we will extract the spatial geometric information of the certain object that we already overlay. Like we will do a clipping, maybe we will do an intersect between these two objects, maybe we want a union of these two objects, or some symmetry different, or any update about the object, and so on. So this one is actually the example for when we for buffer analysis and the overlay analysis, and this one is what we see we can do, or we can create a buffer zone for the line, this one line, region, and also point buffers. And we can do also the sustainability analysis by having a buffer analysis and overlay analysis together. Now we will take a look about the proximity analysis. So under proximity analysis, we can do a T-sum polygon, where for a T-sum polygon, we basically can construct this T-sum polygon from either point, lines, or regions according to a certain distance. So basically for T-sum polygon, mostly we will do for a rainfall intensity, as you can see for this example. Okay, next we will go under proximity analysis function, which we can do a measure. We can measure a distance. So basically, this feature is being used to analyze the shortest distance from points to either points, lines, or regions. So thereby, we can check the relationship between the two group objects. So you can see this one is example. We can analyze the hospital close to each school and the corresponding distance. And we can check which one is the nearest points towards the source, and we can check the shortest distance, and so on. Next, we will take a look on our second content, which is raster spatial analysis. So raster data structure is simple and intuitive, and thus easy to process and operate on using computer. It is basically a basic data format commonly used in GIS. So raster-based spatial analysis are basics of a GIS spatial analysis. So the raster analysis function in the application can be include the setting for the raster analysis environment, surface analysis, statistic, converter, distance raster, interpolation, hydrology, gray value, and so on. So this one is the function where under space analysis, where we can extract isolines and isoregions. We also can do visibility analysis, surface measurement, and also do a terrain calculation. So basically, we can extract all lines, regions, specified line, and also extract lines with point. We can do a visibility between 2 points or among multiple points. We also can do surface measurement for the surface distance, area, and also a volume. We can also do slope or aspect analysis, calculate DEM, to do a 3D shape map, and we can also split DEM. So this one is an example for the surface analysis that we do. So as you can see, this one is when you have data, you can do and extract the ISO regions, extract ISO lines with point where we will extract it, and then we can also do slope analysis, visibility analysis, 3D hill shape map, and also visibility among multiple points. This one is one point, and this one, as you can see, that it is among multiple points. So under it, we will do a vector raster conversion. So basically, for vector raster conversion, we can do a raster data to vector data to a raster data, and we can also do a twin raster, as you can see in these pictures. Okay, now let's take a look on DEM. So we can basically build a DEM. So this one is the feature that is built from an interpolation where we will collect the elevation points or ice lines to generate the DEM data. So this DEM data can be used to describe the spatial distribution of topographic features of the area. So this will be provided as free for DEM, and the SuperMap we will provide a tree interpolation function, which is including spline, inverse distance weighted, and quizzing. So we can also do a deep leak on DEM where we will assign the elevation of the legs which will corresponding to the pixel on the DEM data, where it helps to form a new DEM data to express terrain like lakes, depression, glaciers much better. So basically, we will use the elevation data to do the to create or to correspond the pixels on the DEM data, so we can express the new DEM like for lakes or glaciers, so on. Okay, so for next, we also can do the terrain model next, when we have a different elevation, or the elevation model doesn't match with the elevation of the terrain data. When we add the DEM raster data, when this can sometimes happen, as we know, so we can do we have the features that can adjust the overlaps, thereby making we can have the model fitting the area much perfectly or better. As you can see, there is some here terrain data that are overlapping with the elevation model, with the elevation terrain data. That's why when we adjust the overlapping, we can have this display model and see it much better. Next, we have a density analysis, which under density analysis we have the simple and kernel density analysis. So basically, density analysis helps to measure the quantities of the surrounding each point. But for the kernel, instead of only measure, it will help to calculate the quantities of the surrounding area each point or line by using this kernel function. This one is the formula when we want to do the kernel density analysis. So this one, when we use this density analysis, basically for calculating the population density, building a density, when we want to have the crime reports, and we want to check the population density monitoring of tourism. Next, we can also do a raster statistic. So basically, this raster statistic is where help us to calculate the pixel values of the raster data. Like we can check the minimum, maximum value or the average value and the sum, where this will help us to know about the data distribution much better. So in SuperMap, we provide 5 statistical methods, including the basic statistic, common statistic, zonal, elevation, and also a neighbor statistic. So this one, as you can see, basically we will calculate the pixel value, the rest the data, and it will come out like this. You can see like the mean, the max, the minimum value, the average value, and so on. So the next we do have a distance raster, the raster analysis. So basically the distance raster is being used to calculate the distance from a cell to the adjacent cell, including spatial and across distance. So this distance raster is being provided by application the application can calculate the distance, shortest path, and least cost distance. So you can basically assess the services area that covered by chain by using this function, and you can also check the feature or use the feature to find the hospital that is close to the earthquake zone, where all of these are being analyzed by having the spatial distance from each pixel to its adjacent pixel. Next, we go to the hydrology analysis, where hydrology analysis is also part of the raster spatial analysis. So hydrology analysis basically can help us to understand about the hydrological characteristic of the raster data, where we can calculate the field sink, flow direction, flow length, flow accumulation, subbasin, and so on. So this hydrological analysis basically has been widely used in many fields like regional agriculture and forestry. We can also predict disasters such as flood, and when we do a road design, we can use the hydrology analysis. Okay, so now we're gonna take a look on our 3D spatial analysis in SuperMap iDesktop. So basically in SuperMap iDesktop, we provide a multiple 3D spatial analysis that can be working on a terrain, model, and also image data. So by analyzing the objects and the product or the model and terrain, we can display all of these and analyze the results in a 3D scene. So basically we can do or provide you in our SuperMap desktop the slope aspect analysis, isoline analysis, flooding analysis, visibility analysis, U-shape analysis, sunlight analysis, openness analysis, and profile analysis, skyline, and so on. So this one is the example of the 3D spatial analysis that we can do in iDesktop. So this is, we have the isoline analysis, and we can also do a 3D analysis for the flooding, shadow analysis, skyline analysis, 3D buffer analysis, and also a profile analysis. So not only that, we can also express the 3D bodies for our visual analysis, skyline analysis, openness analysis, and we can also show the shadow body. Now we're gonna take a look on our 3D buffer analysis. So this one, they create a 3D buffer and for the pipeline. So you can check your width, what type of width that you want, how big the width that you want, or how small the width that you want. So this one, when you after you done do the 3D analysis, and this is how it's gonna look like for the buffer analysis. Next, we're going to take a look about the 3D spatial query. So this one we will do a spatial query here. So we can see that the query that we already done also on in 3Ds. This one is for the sunlight analysis. As you can see, we have this sunlight analysis in a voxel grid, so it can show you like which areas have the most sunlight, that has the most sunlight, and doesn't have that much sunlight that are on them, and so on. So this one is for the skyline analysis. We can check the areas that we want using a 3D, our 3D data or our 3D analysis. And this one is the for the video projecting, where for the video projecting, when we want to do a 3D monitoring, we can assess the area of that has been installed to a 3D map. So as you can see in this picture, this one is we can assess the monitors that has been installed in different types of area, and we can project all of these videos into a 3D map. So this one is for the viewshed analysis. You can create a viewshed analysis here. And lastly, we also can do the visibility analysis, where we can draw a point here and check which part is visible and which part is not, which part is visible and which part is invisible. Lastly, for our today's content, we will take a look about the spatial statistic analysis, where in spatial statistic analysis, we can analyze the geographical spatial data and mix it into a statistic. So this one is basically related to the same phenomena or attribute on an adjacent area. So this spatial statistic analysis is basically being built for the statistical relationship through spatial position of data, and then we can discover the spatial connection and the law of the phenomena. So basically there is a statistical, and for this statistical analysis of spatial data, it will focus on the statistically analyzing the non-spatial characteristic between the spatial data and a phenomenon, where we can describe and simulate a phenomenon using a mathematical model. Other than that, for the spatial statistic analysis, it helps to search the randomness, structure, spatial correlation, and dependency of the phenomena. So what can this do? So basically, it helps to describe the distribution of objects in space, which it helps in terms of randomness, clustering rules, and so on. Other than that, when we do the spatial statistical analysis, we can also do the analysis or analyze the statistically significant spatial clustering, which in terms of the hotspot and cold spot or outliers. So we also can do we can also analyze the spatial autocorrelation of the data and effects on the spatial pattern, and how to build model using this relationship that we already find. So basically, for the spatial statistic analysis, this is the tools that has been provided in SuperMap IO desktop, where it has been divided into the 4 classes, which is for measuring geographic distribution, analyzing mode, cluster distribution, modeling spatial relationship, and utilities tool. So as you can see, under measuring geographic distribution, we can do the central element. We can analyze the mean center, median, directional distribution, linear, directional mean, and also do the standard distance. While for analyzing mode, we can do the spatial autocorrelation, high or low clustering, average nearest neighbor, and we can check the geographic detector. For the clustering analysis, we can do the cluster and outlier analysis, hotspot analysis, and we can also optimize the hotspot analysis that we already analyzed. We also have the modeling spatial relationship, where for the statistic analysis, it helps to with the regression analysis, and we can also do the ordinary least squares. Lastly, for the utilities, it helps to collect the events and generate the spatial width matrix for when we do the spatial statistic analysis. So we will focus on the clustering analysis. So clustering and outlier analysis. So basically, it helps to identify the hotspots, cold spots, and abnormal space value with crowding and significance. So these weighted features are being analyzed by using the Ensling local Morans one. So we have the sample application here, which we can sample application or simple question that when you want to do it, where this is some of the question that you can check, which is about the unexpectedly high rates of sickness like diabetes across the study area. We can also, when we want to check where are the location in the study area if we have anomalous spending patterns. So when you have the spending patterns, or you want to check where is the places of the study areas, you can do this clustering analysis. So under clustering analysis, we also have the density cluster, where this tool can classify the dense point as a cluster. So this tool provides the 3 clustering methods, which including the density clustering, hierarchical clustering, and ordering clustering. So this is an example when we done with after we do our density cluster, and we also can check its graph. So for the hotspot analysis and the clustering analysis, we will give a set of weighted features, where after that we can identify the hotspot, and we can do the hotspot analysis by identify the statistically significant hotspot and cold spot using the local general G index statistic. So with this, we can optimize the hotspot analysis by using the parameter that has been derived from the characteristic of the input data, which it helps to perform the hotspot analysis and reflects the distribution of the hotspots and cold spots. So this is the sample application that can be done, which the application we can do is crime analysis, voting pattern analysis, economic geographic, retail analysis, demographic, traffic incident analysis, and so on. So this is how it will come out on your map, and you can check it on through your legend, like the difference in color give you like the difference analysis, and so it helps you to understand and see much better on your map. after you're done with your analysis. Okay, now we will take a break for a few minutes. So before we go to our next section, which is a live demonstration. So thank you.
All right. Thank you, Shafika. So now we will have a 5-minute breaks. So you guys can bring something or anything. So we will come back in 5 minutes for a live demonstration in how to do the spatial analysis. All right. Thank you. See you in 5 minutes. Right. Welcome back everyone from the 5 minute breaks. So right now, we will continue our second session for the live demonstration. Okay, as usual, if you have any question, just type in the Q&A chat box.
So hello and welcome back everyone. I hope all of you are feeling fresh and have a nice toilet break or some drinks breaks. So now let's start with our live demonstration where we're going to create some analysis for a buffer and overlay under which is under vector analysis, and then we will also do some raster analysis, which is a 3D sheet, and we will also extract some ISO regions from the data that we have. So I hope all of you are ready right now to do together for our live demonstration, or you may take a look first before creating the analysis or the data later. Now we will go to our desktops. Okay, so now as I already shared to you guys the data source that we have, so you just need to import it and open it into our iDesktop, and then after you open and import the data set, the data source, you're going to have this data set under modeling and analysis. So you can just add these two data set into a new map. So after you add it into the new map, okay, this is how it looks like for the data. You go to the spatial analysis, and since today we are going to focus on our spatial analysis, this is the under spatial analysis that we have, which we have a query, vector analysis, which is buffer, overlay, and proximity analysis, facility network analysis, raster analysis, which we have many, which is a surface analysis, vector or raster conversion. We can build a DEM, we can do a raster statistic, distance raster density analysis, interpolation analysis, solar radiation, hydrological analysis, and so on. So now back to our modeling and analysis. So we're going to focus on vector analysis for this first part, where we're going to create a buffer zone first before we do the overlay analysis and open it on our 3D scene. So we're going to click this one. Oh, I'm sorry. So before we click this buffer zone, we're going to take a look on this browse associated table. So I'm going to take a look on the root name because I want to do the buffer on the Xingyi root. So now I'm going to check a Xingyi root. You can just click this root name, so it will come out on the map which root are you clicking right now. So I'm going to click I'm going to find the Xingyi root. Okay, this is the Xingyi root that I want to do the buffer. So I'm going to close it, and then I'm going to go back to this spatial analysis and click this buffer zone. Okay, so as we know that under buffer zone we can create the buffer for a line or point and region. So right now I'm going to do a buffer for a line, so I'm just going to let it be underlined. So you can change it whether you want your buffer to be flat or round. So I'm going to make it flat, and then you can change the radius depending on what you want. If you want it to be the width to be much more bigger, you can just add or increase this radius left or right. Then this is the dataset name that I'm going to save it later, which is under buffer. So I'm just going to click OK here. So this is the buffer I already create, which is I'm creating it flat, so this is how it looks like because it flats. So you can change the color as usual on the layer style. You can change like the color. You want to change it into light green or yellow or pink. It is all depends on you. So I'm going to just let it to become a blue one. So you can change the line colors to as usual. That one. I'm sorry. Okay, so after we're done with our buffer, we're going to do some spatial query. So click this spatial query under query, which is also under spatial analysis tab, and then you can click this model region, and under spatial query condition, I'm going to do because I want to check which building will be affected if I'm going to expand my route into like 20 meter and so on. So I'm going to check the intersect line region, and then I'm going to set the query distance into 20 meters only, and I'm going to see the results and click this query one. Okay, so as you can see here, okay, this one the attribute table that you already clicked, it will come out also. So I'm going to directly focus on this one first. So as you can see on this one, and this is the building that will be affected if you like expand your route into like 20 meters and more. So I'm just going to close this one. So I'm going to open the one that we already name. Okay, so this is the building and the route, and I already do some buffer and overlay analysis. So okay, from this we are already done with our buffer and modeling analysis. Okay, so now we are going to do raster analysis since we're already done with our vector analysis. So as you know that raster analysis that we want to create today is we want to extract the ISO line. But before we extract the ISO line, I want to do some interpolation. So before that, before that, I want to tell you that after you import the data set, the data source here under raster analysis name, there is going to be one data set only, which is points_3. So from this point, we're going to do some interpolation. So you can go to the spatial analysis, and then as you know that there is a query, vector, facility, and also raster analysis. So we're going to click this raster analysis under the interpolation analysis. So as you know, there is a spline, quizzing. We have ordinary, simple, and universal quizzing. So I'm going to use IDW to create my interpolation, to do the interpolation analysis. So I'm going to click this IDW. So this one is what you're going to see after you click this IDW. So you can see there is this data set name, which we're going to have it from points 3, and then the scale factor, we're going to have one here. And then the fields that we want to do is SMID, the result, the dataset name here, which is the result data, you can change here into the interpolation. So you can change the resolution, and this is the pixel format that we have, which is bit 32, and we also have another pixel formats here. So for the sample point setting, you can either change it into the fixed radius or the fixed count. So I'm going to make it as a fixed count before I run it for this to be fun. so you can just double click it to open it. Okay, so this is the interpolation analysis that I already create from this point. I'm sorry. Sorry. Okay, so after we create this interpolation, we're going to extract the isolines from this. Okay, so we will want to extract the isolines. We will click this Spatial Analysis tab again, and we will go under Raster Analysis. Under Surface Analysis, as you can see, there is a lot of other analysis that you can do, which we can do the visibility analysis, terrain calculation, extract isolines, and surface measure. So right now I'm going to extract the isolines. Okay, so under extract isoline, we have like, we can extract isoline by click, we can extract given isoline, extract isoline by point, extract iso region, given iso region, and extract the 3D data. So right now I'm just going to show you about how we can do to extract the isoline. So you can just click this one. Okay, so this one is the parameter of when you already click the extract isoline. So you can see the data set that we want, I mean the source data set that we do to extract this isoline is from the interpolation that we already created previously. And then this one is the parameter setting. We can change the data value, interval, resample coefficient, smoothness coefficient. You can either you want to change it to B-spline or polish, or you can just make it as none. You can also change, you can have smoothness, and this one will be your result info. Okay, so this one is your result data, where you can change the data set name here. So I'm going just to put it as isoline, and I also want to change my interval into 2 for my parameter setting. So once you change it, this result info will change a little bit. So and then I'm going to run this thing, and then going to drag it here, and as you, okay, so maybe you can't see that. So this is the isoline that I already extract from our interpolation analysis. So this is our isoline and interpolation for our raster analysis. Okay, now we will do some hill sheet. So I'm going to start this one first. Okay, so now we are going to do some hill sheet, 3D hill sheet. So you need to add a new data source into your desktop, which is under the names of training. So after you add it, you can just double click it, and you can see this is how it looks like. So after that, we will directly go to the spatial analysis, and then under spatial analysis we will go under raster analysis. And this one is if like you want to build a DEM here. Okay, so I'm going to just directly do the surface analysis, which it falls under the terrain calculate, where under terrain calculate, as you can see, we can do a slope analysis, aspect analysis, profile analysis, split DEM curvature, cut fill, orthophoto image, draw polygon, region find, inverse cut fill region, and a 3D hill shape map. So I'm going to do a 3D hill shape map. So I'm just going to click this 3D hill shape map. Okay, so here, as you can see, you can change the parameter setting into this azimuths. Like either you want it changed to what azimuths that you want. You can change the altitude angle also, the shadow mode, if you want it to be illumination only, or shadow, or illumination and shadow. And you can also change the Z factor, and you can also change the dataset name as usual. I'm going to change it to show sheet. So I'm going to run this one. Okay, so I'm going to just open this. Okay, so this is the hillshade that already created. So if you open these two together, okay, you can just move it the data set first into the bottom one, or if you want to move, you can just move like this. Okay, just drag it. So this one, as you can see the bottom layers that well. So you can change, of course we're going to change the layer we're going to I'm sorry, set the color table. So as we know that for DAM, hillshade has its own color, which is the black and white. So I'm going to click this one. Okay, either it's going to look like this, or it's going to look like this, depends on you. Or if you want to change the colors here, so you can just change it and click OK. Okay, so I'm going to go to the layer properties and change its transparency, where I'm going to make it at 17. So this one is once I change the layer transparent, so it makes my from this layer which it is not that 3D to become much 3D, since we already do the spatial analysis, which is the surface analysis, which make it this hillshade become 3D. As you can see, it's 3D. So you can change the transparency colors here depending on what you want, and either you want to make it like high, or you want to make it into like maybe you want to change it to 80 or others than that. You can just change this transparency colors here. Okay, so you can also change the brightness, the colors, the color maps in this setting here, the grid function, the scales, the minimum scales, and so on. So yes, I think that's all for today, which we already done the vector analysis and raster analysis for our spatial analysis with SuperMap. So for maybe for 3D analysis, I will show you the next time we do the skills the workshop, or you can just check it on our YouTube channel, where one of the analysis for the 3D we already done for the flat analysis on our YouTube channel. So you can try check it there. For the short video, I will upload it later on how you can directly create other spatial analysis here that we can cover today. So I think that's all from me. Thank you and have a nice day.
So if you guys have any more question on this today's training, which is on the raster analysis, just let us know, or you can just send us an email later. So yeah, we are open for the Q&A for you guys. So if you guys miss any point or any content on today's training, you can just rewatch it again on YouTube channel. All of them are there, even the previous week as well. Okay, so I think Shin already answered a few of the questions. So you can, okay, so I would like to welcome all of you. If you would like to submit your result, if you want us to check if your result is correct or not, you can just submit it here. So for this week is week 6, so you can just click on this week 6 and just upload your result, and we will check. So the final submission date will be on 14 December. So as your certificate, we will send to you in after 2 weeks of our last training, which is on week 10, 7 December. Okay, so I hope to see you all again next week for week 7, which will be learning on the traffic analysis. Okay, so thank you so much everyone for attending to this training. Okay, have a nice day. Thank you so much. Bye-bye.